Hello everyone, it's March 20th. All right, so March 20th it is. I just finished the contest. Well, it was very bad time these days because there's no more, there's no, we switched to daylight saving time and it's gonna stay. And because of this, the contest, instead of starting at 9:30, it starts at 10:30 p.m. for me and it ends at midnight. So that's one bad thing. Well, I didn't do very well this time. I shouldn't say that. I mean, I finished like on the record, it's like 1 hour 20 minutes, but for three questions, not four. But in fact, it was not that bad because I was earlier doing something else. I wasn't able to start the contest immediately. I mean, we were trying to have find an apartment, and apartment hunting is always very nerve-wracking. It's the good ones are so far in between, and you always have this decision, whether you want to get this one or you want to wait for something better to come up. And we had some scare earlier. We thought of one apartment that's really good, very nice, and we really tried to get that, and suddenly it disappeared. And we got really worried. But everything turns out fine so far. And then I submitted the application right before the contest. And the reason I got late into the contest because of a stupid software to verify ID. It just took forever to get the verification done. But anyway, I didn't go into the contest with a clear mind. The head, it was, I was not in a good space in my head. I was tired and was not really in a good state. And the problems are kind of, they're not hard per se, the first three problems, but there are so much stuff to read. Like each problem has so long a description, and since my mind is not at its peak, like a performance, I read slowly, really slowly. It took me a while to understand them. And of course, I also got a problem wrong on the third one, so that added 5 more minutes. But it's fine. It's fine. Eventually, I mean, I haven't had a good performance for 2 weeks consecutively. But what can we do? I mean, from now on, it's gonna be late on Saturday, so I don't expect good performance at all. All right, so these are the complaints, and actually the last one. So this is the last problem. This one. This is the last problem. It's very tough. Very tough. I have no clue. Very good problem. I actually really want to know how this one can be solved. And I see there are four hints. It's actually good, so I want to know. This is a very good problem. All right. Anyway, so let's do for today minimum domino rotations. Have we done this before? Oh yeah, we have. Ooh, look at this. Seems to be a pretty tough one. All right, let's see. Oh wait, when did we do? 2020. In a row of dominoes, tops I and bottoms I represent the top and the bottom halves of the ith domino. Now I understand what they are. I think back then I didn't know, but now I do because I've played domino. We may rotate the ith domino so that tops I and bottoms I swap. Return the minimum number of rotations so that all the values in tops are the same, or all the values in bottom are the same. If it cannot be done, return -1. Well. Two rotations. Nice. Example 2. It cannot be done. Okay, so the minimum number of rotations. And I have 2 to the 10 to the 4th. All right, let's say we have 1. That's 0 rotations, right? Now let's say we have 2, right? To determine the minimum rotation, we check, right? If they already matched, then that's nothing, right? Otherwise, um, otherwise we can, if there's match, then we match, right? Now there is a problem. Maybe we need to look through the entire thing because it's asking whether the whole top and the whole bottom can be matched, which means we can count, right? We can do a counter, and but the two values we also need to check. So this should be like a dominant number, right? So we do a counter and then we find the numbers that are larger or equal to the length, right? So for those numbers, then we can check, right? We're going to check. Check for what? Check for their positions on the top and position on the bottom to see if they can indeed fill. So we check for that numbers on the top, and we find out which position it doesn't have, and we check on the bottom and to see if those positions are there. If they are, that means so we check the position on the top. So we have whatever positions on the top. So we have, say, a few positions that's not available. And then we check the position at the bottom, and on the bottom we also have certain positions that's available, right? So we have some positions available at the top, we have certain positions available. And then we just need to know if they overlap, like the not available. So be available on the top and not available on the top. And then when going down, well, if this one can be done, then we already know, right? Yeah, then we can. Yeah, so we just all we need to check is on the bottom if those positions are available. Those positions are twos, are the ones. So we go through those positions and then see if they are available. If they're all available, then the minimum number of swap is just the smaller of these two values. And then we go for the next value, and then we go for the next value. So what we can do is we don't even need to do a counter. We need to do an indices. So for the top, I need indices for all the same values on the bottom as well, right? And then I can loop through 1 to 6 because there are only 6. So loop through 1 to 6, and for each one we count what's the total number of occurrences. If occurrences are smaller than the length, then that's not possible. If it is, right? If it is, then we go for the top, and then we go for the top, and we want to know which ones are missing, right? Then we need to go through everything, and once it's missing, how do I know which one is missing immediately? I was just thinking you just need to do one by one. Yeah, this maybe one by one is the way to go. You just go 0 to the end, and you do top that. Is that a? But I already checked. I think there gotta be an easier way to handle this, right? We can create an array and then we just put a top in, put a bottoms in, right? Put tops in and bottoms in and then see if there's any for the top. Yeah, we filled it and then we okay. I can do that. I can do that. And once we confirm that a certain value can indeed um, fulfill, right? Can indeed fulfill. So counter, check, check, check. The first one that can do, yeah, so we only have 6. Hold on, we only have 6. So why don't we just, for each one, we just check. So 6 times 10 to the 4th. All right? That's it. We'll go through every one for every one. But then, if you're not good, like if we start from 1, right? And then we say tops 1 is not tops this, that's not going to happen. Yeah, I think this one will work. I was like thinking about something like smart, but I don't think it's necessary. I think we just go through every one because the tiles are 1 to 6. So we can just go through 1 to 6 for each one. We check. We'll see if it works. If it doesn't work, then it doesn't work. Yeah, because if you want to do counter, it's gonna do. Will counter be faster? Think about it. If you do counter, we do 1, right? So we need to do counter on this, counter on that. So that's 2 times. You have to go through the whole thing. So 2n. And then you go 1 by 1. And 1, 2, 3. So if it's not good, you don't have to check them, right? And if some is good, then you check. If you don't do that, then we have 6n. That the runtime is 6n. So either 2n with maybe 1. Yeah, if it's possible, maybe 1 or 2. Yeah, I think counter is actually going to be faster. You can save some bandwidth, right? Yeah, let's do counter. So we're going to say top C equals counter tops, bot C equals counter bottoms, right? So we have 2 counters, and then we just say for a tile in range from 1 to 6, right? 1 to, I have to do 1 to 7, and we say if top C T plus bot C T is smaller than, we can give n equal to len tops. If it's smaller than n, continue, right? We don't do anything. If it's larger or equal to n, then what we're gonna do is, I don't know. But you have the count. This actually doesn't help. Wait, hold on. Does it help? But because I want the minimum swap, right? So now I go through every single one, and if it's top and a bottom, if it has top, has bottom, that's a good, right? And if it doesn't have top, it has bottom. So I need to keep track of how much is missing on the top, right? Okay, so how much is missing on the top? Yeah, let's just keep how much is missing on the top, and I have the top count, right? Then I know which one I need, how many I need to swap. Okay, so missing at the top. So we have a result. Okay, rest equals to 0. Okay, so we say miss at the top is equal to 0. Right. So we're gonna say for I in range n. Okay, and then we say if tops I is not equals to t, and bottoms I is equal to t, right? Then that's a miss top plus equal 1. Okay. Aleph so if top I is t, then we just skip, right? So if top I is not equal to t, right? Then we say if bottom, then if bottom is not, then we break, right? And else, which means if we break, we don't do else. Else is we go through the entire thing, so which means it's good. Then rest shall equal to the minimum rest, or minimum swap. Then it's the minimum miss top, which means we have to swap the bottom, or top C T is the total number on the top. Right, so total number on the top, and the number need to swap. Right, so we need to pick the smaller one. So either the miss top, which means swap the bottom up, or the top T is from the top to the bottom. So it's going to be this. And then we go through the entire thing, and then we return rest. All right, let's take a look. All right, the first one shall equal to 2. Second one shall equal to, oh, shoot. We need to get minus 1. Minimum. This has to be math.infinite. Return res if, now return minus 1 if res is equal to math.inf, which means I've never done this one. Else res. That shall work. Alright, so this we have tops and bottoms. Minimum tops and bottoms. Alright, it works. I'm not sure. I am not sure. Let's try it. It doesn't matter if you're wrong, it is wrong. Hey, got it wrong. Alright, let's see. I thought we handled this situation. You know what? I think this is probably the same test case I got wrong last time. It is one. One swap, two swap down. I thought I handled the situation. Miss top. Oh, I see. I need to consider top and bottom. Alright, so let's do miss top and miss bottom. I have to do both. So this is E not equal to T. Alright, we can do this. If this, no, I want both. How'd you write that? Well, if this, and then if tops I is equal to T and bottoms I is not equal to T, right? In this case, miss bottom is plus equal 1, right? And if tops I is not equal to T and bottoms I is not equal to T, then break. And we have to do this because I want to check both, right? They both need to be checked. Yeah, they both need to be checked. And then it's gonna be and another miss bottom and bottoms T. No, bot C T. Yep. All right, let's try this one. Yep, that is correct. Yeah, I'm pretty sure I got it wrong in the exact same spot. I'm curious. I'm very curious. This was the error case I had last time. Yeah, exactly. Exactly the same thing. Exactly the same thing. Oh, what the hell is this? Oh, I don't like it. Exactly the same test case I got wrong. 81 test cases. Alright, let's see. This one probably is the best solution I had. Alright. How should we call it? We call it this way. So 1007. Okay. We first use counter to check to obtain the counter on tops and bottoms. Then we go. Then we check tiles 1 to 6. Right. For each tile, we first check whether the total number of occurrences, right, of the tile is larger or equal to len tops. If not, this tile cannot fill all top or all bottom. If the number is larger or equal to len tops, right? Then we check whether coverage is possible. We go we iterate through, right, all positions and keep count of how many missing spots there are on top and bottom. If at any position neither top or bottom has the current tile, the current tile cannot cover. Otherwise, after confirming that the current tile can cover top or bottom, we compare, right? We compare the number of swaps needed. If bottom swaps to top or the other way around. So this is 6n at the most. And I hit 1858, 21. All right, so the 3 test cases is the same. Okay, this is a good solution I had. 99. Oof. Wait, count swap. What is this? What? Wait, what? What the hell is this? Either A or B has to have the same number throughout, so we can just check the possibility of using first number of each list. I don't even understand what I was trying to say. Count swaps. Count the number of swaps needed. So I given a base list and then given the swap list and the target. So if a value is not equal to target, swap I is equal to target plus equal to 1. Else swap list. If in the base the value is not equal to, and if in a swap it is true. Hold on. Count swap AB. We pick A as the base, B is the swap list, and A0 as the target. I don't understand. If val is not equal to target, but it's in the swap is, that means, okay, that's a swap. We need to do a swap, right? Okay, plus equal 1. Why minus equal 1 here? 0 and plus equal 1, so that's like do one swap, right? And then if next one val is not equal to, and this is also not equal to, the rest minus equal 1. Alright, this piece is interesting. I don't understand. Why minus equal 1? What if I already swap a lot of times and now I cannot swap and rest minus equal 1? Alright, this one's weird, okay? This is weird. But anyway, so this one I says I want to do AB based on A0. How many times I need to swap? AB based on B0. AB based on B0. How many times I need to swap? If both are larger or equal to 0, I think that's why I do minus equal 1. It's like a signal, sentinel, right? But hold on, if both are larger or equal to 0, rest A equals minimum of these two. Oh. Oh my god, I see. Oh wow. And this is not minus equal 1. I just realized it's equal to minus 1. I see. Oh, yes. Yes, 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 yes. Because eventually, so yeah, we only need to consider 0. So, so either B swap to A or A swap to, like either B swap up or use A0, right? So if we use A0, I think I can use this. If we use A0, we can count how much, and we can count how much as well. So we can't swap. A0, A, so B swap into A based on A0, based on B0, right? So we have this value. If both are larger or equal to 0, then I grab this. So what is this? I don't know. Isn't this just this? No. It's like if one of them is minus, hold on. One of them is a minus 1. Wait. So we're trying to say I want to swap based on this value, right? If I get a value. And I swap based on this value. Yeah, which is if both are negative, then it becomes minus 1. If both are positive, it's equal to this. If one is positive, the other is negative, I pick this. Ah, I see. That's the thing. So we do this, and good solution. I'd probably do it slightly differently. I think I'll do it slightly differently. But the basic idea is the same. So this solution is from the one submitted on. Yeah, let's not look at this and try to do it ourselves. 10/19, 2020. 2020, 10/19. Now the key observation is that to make the swap work, the top and bottoms, right, must conform to either tops 0 and bottoms 0. Thus, these are the only two values that need to check. So basically, I can just run this, right? I think I can copy this, and that's fine. And for t in basically two values, tops 0 and bottom 0. So we check these two values. Actually, let's do a set. All right. It doesn't matter. We don't. We just do this. Right. Oh, I need this. We might want counter. Damn, can I not use counter? Can we do this without counter? No, I think counter helps. Counter is just 2n, 3n, 4n. This is 4n, right? So we only need to check these two. And then we count a miss, right? I have a miss top, miss bottom. And then, yeah, solution 2. Oh, my bad. I have to do this. Yep. So the only difference is I can avoid doing too many checks, but overall I think it's the same. I don't know. So like we're not going from 1, 2, 3, 4. We're doing this. And I don't know how much savings we can have because with the counter, all right. I guess there is savings. Yeah, we can avoid. Yeah, it makes sense, right? So the top and bottom. We should actually do this as well. Right? We should do this one as well. Which I think can probably save even more. I don't know. Try it again. Can I save even more? That's fine. So only consider two values. I like this. I like this one better, right? Because we use a counter, and then when we calculate which one to pick, it's just the missing, right? The missing ones needs to swap. All right, that'll be it. That'll be it for today. I'll see you guys tomorrow. Adios.